Hello everyone, this is Dr. Ali, and we want to continue with dynamic programming for actually the knapsack problem. We already discussed that what is the formula that we want to follow for filling the table for this dynamic programming. And I promise that I'll give you another example, maybe a better example that show which when there maybe when we skip some of the items, because in this example that we follow, we actually included all the items. So maybe that wasn't a good example, but here I brought a better example with the coding. Okay. So let's say that actually it is the same problem, the same numbers that we used for giving the actual for recursion and also that evolutionary algorithms. We use the same numbers, just in sake for the comparison that this is the correct or they're giving us the same solution or not. So we have this weight, we have the values and the maximum weight actually. Then I create this table. First, all the items in this table, I set it to 0. That's why I use numpy as 0. Then I just traverse this table, and each time I check if the weight of that item that I wanted to add, if it is greater than this current column, then just use the actual use the item above it. So here, for example, use the item above. So it's 3, use 3 because the weight that we are using for item 2 is above or is past the available space in the knapsack. So we just use whatever the current value of the knapsack is, considering only item 1. And then if it is not true, then we come here and using the updated table, using the max, this formula that I already explained, here, we just implement it. We say what is the maximum between the cell above it, above this current cell that we want to find out the value, and the summation of the current value of the current value of this object under evaluation plus the value of the table at the row above it, and the J is the weight of the current column minus the weight of the item that we wanted to add. So between them, the maximum between them, then we keep updating, and it will the item, the value at the actually the table index -1 and -1 is give us the value at the cell on the right and the bottom right. So that is the cell -1 and -1. So then we know that it is 120. That we already saw this with the other actual the other methods, recursion and the evolutionary algorithm. That all of them they gave us the same number. But if and then we printed here the table that see what is the numbers in the tables are look like. And when you look at here, this cell -1 and -1 is referring to this item, which is 120. And if we want to look at, okay, what are the items that are included and what are items are not included? Because this is just a value. It says, okay, we found this a sequence that if you follow that sequence, it will give you 120 and it is optimal. But but I want to know what is that actual item that we include. So as I said, you need to start from this location and go up till you reach the location that these two cells above each other, they're different. So here and here, both of them have the same number. So that's what's happening here. It says the value of I and j compared to the cell above it. If it is not equal, then it means that that item actually included, right? And I think it's clear why, right? Because these two have the same number, right? And this is the for item n -1, and this is for item n. So when these two have the same number, it means that we didn't include item n -1, because if we included it, this value couldn't be 0, right? So it should have some value here. So when it is the same, it means we didn't include it. So we go all the way up till we reach this point. These two are different. So it means that whatever the item was for value for this item was, we included it here. But so this item actually is this value, because this is the first item that is one. We started from actually end toward the beginning. So this is the first I, and then when the and then we reduce the j, which the j is actually keep tracking of the column index. So we say that reduce the column index by the weight of that item that we already put one there. So the weight of the item, reduce it, and then we jump to the next column. And then we keep doing this till we reach either to this zero here or this is zero column. So if we keep doing this iteration, then we reach this sequence that is actually the same sequence that the other methods also gave us. So you can, I'll share this code, you can play with it and you can compare it with the other solutions for the other techniques that we covered. And that's it for today. If you have any comments or questions, please leave it down below. And yeah, have a great day till next, stay tuned to the next video.